I will explain how to determine the percent composition of an element in a compound. Let's begin with a very simple compound, sodium oxide. Suppose I wish to determine the percentage of oxygen in this compound. Well, the first step will be to refer to the percent composition formula, where percent composition, in this case percent of oxygen, of O, is equal to part in grams over whole, also in grams, times 100. Now let me explain what I mean. The first step now is to determine the mass of the entire compound. Notice that the compound contains two sodiums, and from the periodic table, the rounded mass of sodium will be 23 grams. So we multiply 2 times 23 grams, which is equal to 46 grams of sodium. And there is one oxygen atom, so we multiply 1 times 16 grams for 16 grams. Now we simply add the masses. And after adding the masses, the sum will be 62 grams. Now, this represents the whole, the total. What about the part? Well, the part will be the mass of the oxygen. So to complete the calculation, we simply divide 16 grams by 62 grams times 100. Of course, this is percent of oxygen. All right, now what we have here on the New York State Regents exam is called a numerical setup. So if you're asked to write the numerical setup for calculating the percentage of oxygen in the compound sodium oxide, this is what you want to write. The calculated result will be 16 divided by 62, 25% oxygen. So the compound contains 25% oxygen. And that's basically how to perform the calculation. But let's do a couple more just to be sure that you understand. Let's do a slightly more complicated compound. How about the compound barium hydroxide? All right? So let's begin by determining the mass of the compound. Clearly, the compound contains one barium, but it also contains oxygen and hydrogen. The best way to determine the molar mass or formula mass of the compound is to distribute the two. This is called atom counting. BaO2H2. So the compound contains one barium, where from the periodic table, the mass of barium is equal to 137. So it's 1 times 137 grams. There are two oxygens. The mass of oxygen will be rounded to 16 grams. And there are two hydrogens. The mass of hydrogen rounds to 1 gram. So we have two of those, 1 gram. 137 grams. 2 times 16, 32 grams. And 2 times 1, 2 grams. Now we simply add the masses. And the sum will be 171 grams. This represents the whole, the total mass. So to determine the percentage of barium in the compound, let's determine the percentage of barium. So percent barium, Ba, is equal to part, which will be 137 grams, divided by the total, which is 171 grams, times 100. Remember, this will be our numerical setup here, okay? And the calculated result will be 80%. So this compound is 80% barium, 80% Ba. One more, then we're done. Okay, how about a compound with a funny looking character in its name? The compound iron 3 carbonate, iron 3. Since the compound has the name iron 3 carbonate, the Roman numeral 3 tells us exactly which oxidation state to use. So we're using the iron, cation, that has a +3 charge. And carbonate from table E, or a table of polyatomic ions, okay? Now, on a table of polyatomic ions, the charge of carbonate will be -2. Clearly, +3 does not cancel -2, so it doesn't equal 0. I had initially started to write parentheses here for the simple fact that I knew the oxidation states wouldn't cancel out, and I'm going to have to crisscross. But since carbonate is found on table E, or a table of polyatomic ions, okay, if we crisscross with a number greater than 1, in other words, we're going to bring a 3 down, greater than 1, then the polyatomic ion must be placed in a parenthesis. Okay, very important to remember that. So now let's complete the crisscross. 3 and 2. And that's the formula for iron 3 carbonate. Now let's determine the percentage of iron. At this point, we now have to eliminate the parentheses since we have the correct formula written, and the number of atoms, or moles of atoms, becomes 2 moles of iron, 3 moles of carbon, and 9 moles of oxygen. So that's how it works. Now we may determine the total mass of the compound. For the periodic table, the mass of iron will round to 56. So we have 2 times 56 grams. We have 3 times 12 grams. And we have 9 times 16 grams. All of these masses will come from the periodic table. Okay? 2 times 56, 112 grams. 3 times 12, 36 grams. And 9 times 16 will be 144 grams. Now we add them all up to get the total, and the sum will be 292 grams. This represents the total. This represents the whole. Now, the part, which will be percent iron, will be 112 grams over the total, 292 grams, times 100. Remember, this will be the numerical setup for determining the percentage of iron, and the calculated result will be 38%. And this basically explains how to determine the percentage of an element in a compound. Hey, thanks for watching. See you next time.